Hello biologists, in today's daily revision task, you are asked to produce a revision clock on the effects of pH, temperature, enzyme concentration and substrate concentration on enzyme activity. Hello and welcome to this A-level biology revision video on enzyme action and the factors that affect enzyme action. Right, factors that affect enzyme action usually come up in most enzyme questions somewhere, so it's important to know the key points. The activity of an enzyme is affected by its environmental conditions. Change in these alter the rate of reaction caused by the enzyme. In nature, organisms adjust the conditions of their enzymes to produce an optimum rate of reaction where necessary, or they may have enzymes which are adapted to function well in extreme conditions where they live. Right, the first enzyme or the first factor that we want to look at is temperature. So increasing the temperature increases the kinetic energy of the molecules. In a fluid, this means that there are more random collisions between molecules per unit of time. Since enzymes catalyze reactions by randomly colliding with substrate molecules, increasing temperature increases the rate of reaction, so more product is formed. However, increasing temperature also increases the vibrational energy that molecules have, specifically in the case of enzyme molecules, which put strain on the bonds that hold them together. So this is the bond that is holding the quaternary and tertiary structures together. As temperature increases, more bonds, especially the weaker hydrogen bonds and ionic bonds, will break as a result of the strain. Breaking bonds within the enzymes cause the active site to change or the active site to be lost. This change in shape means that the active site is less complementary to the shape of the substrate, so that it is less likely to catalyze the reaction. Eventually, the enzyme will no longer work, and at this point we say it's become denatured. Right, remember that we can't refer to an enzyme as being killed because an enzyme is a protein, so is not living. The temperature at which the maximum rate of reaction occurred is called the enzyme's optimum temperature. This is different for different enzymes. Most enzymes in the human body have an optimum temperature around 37 degrees, which is why on the graph the rate of reaction increases as we approach 37 degrees. However, after 37 degrees, the enzymes become denatured, so the rate of reaction goes back down to 0. In summary, as temperature increases, initially the rate of reaction increases because of the increased kinetic energy. However, the effect of bond breaking will become greater and greater, and the rate of reaction will begin to decrease after a certain point. pH measures the acidity and base salinity of a solution. It is a measure of hydrogen ions, which are H+ ions, and therefore a good indicator of the hydroxide ion, which is OH. In this case, we talk about hydrogen ions as being the hydrogen ion concentration and OH ions or hydroxide ions as being the OH concentration. It ranges from pH 1 to pH 14. Lower pH values mean a higher H+ concentration and lower OH concentrations, and vice versa when we approach pH 14. Acid solutions have pH values below 7, and basic solutions, which are alkalis or bases, have a pH value above 7. Deionized water is at pH 7, which means it is termed neutral. H+ and OH- ions are charged and therefore interfere with hydrogen and ionic bonds that hold together an enzyme, since they will be attracted or repelled by the charges created by the bonds. This interference causes a change in the shape of the enzyme and, more importantly, a change in its active site. Different enzymes have different optimum pH values. This is the pH value at which the bonds within them are influenced by H+ and OH- ions in such a way that their shape, or the shape of their active site, is most complementary to the shape of the substrate that they will be catalyzing the breakdown or production of. At the optimum pH, the rate of reaction is at its optimum. Any change in pH value above or below the optimum will quickly cause a decrease in the rate of reaction, since more of the enzyme molecules will have active sites whose shapes will not be complementary to the substrate. So small changes in pH above or below the optimum do not, however, cause a permanent change to the enzyme, since the hydrogen bonds can be reformed. However, extreme changes in pH can cause the enzymes to be permanently denatured and lose their function. Enzymes in different locations have different optimum pHs, since their environmental conditions may be different. For example, the enzyme pepsin functions best at around pH 2 and is found in the stomach, which contains hydrochloric acid, which is also at pH 2. Changing the enzyme substrate concentrations affects the rate of reaction of an enzyme catalyzed reaction. Controlling these factors in a cell is one way that an organism regulates its enzyme activity and so its metabolism. Changing the concentration of a substance only affects the rate of reaction if it is a limiting factor. So that is, it is the factor that is stopping the reaction from proceeding at a higher rate. If the limiting factor increase in concentration will increase the rate of reaction up to a point, after which any increase will not affect the rate of reaction. This is because there will no longer be enough enzymes to continue to catalyze it, so therefore the enzyme concentration will become the limiting factor. You can see on the upper graph on the right hand side how the rate of reaction increases as enzyme concentration increases. This is because the more enzymes you've got, the more reactions they can catalyze. However, the substrate concentration only increases the rate of reaction up to a point. The point that it stops increasing is the point at which there are no free enzyme active sites to continue catalyzing the reaction to make it go faster. As the reaction proceeds, the rate of reaction will decrease since the substrate gets used up. The highest rate of reaction, known as the initial reaction rate, is the maximum reaction rate for an enzyme in an experimental solution. Right, so go make sure that you've watched the other videos on enzymes. Go have a go at some enzyme questions. I hope that this video has been useful, and if you're approaching your exams, good luck. Hopefully this video should have helped you complete your daily revision task. Please subscribe so you can keep up to date with other videos to help with your daily revision tasks. You can follow me on Facebook or follow me on Twitter to help you keep up to date.